Now let's run it. We should get a bunch of different ships that are attacking us. Oh god. So we got our little ship over here. We'll take him out. Oh god, we got the big guy. He's shooting rockets at me! Oh god, I need to get out of here. Oh no, they're all after me, baby! Oh god, this is so bad. Just keep going. You little crappy ships, get out of here. Woo! Yeah! What's up, everybody? Axe Wizard here. When last we left off, we implemented some more sound effects and stuff, and now I'm still just fighting these stupid ships that don't do anything. So, what I think I'm going to start doing is I'm going to start on implementing AI. So, I'm not sure how I want to handle that. So, I know typically how I do it is I do something that's like I think it's called a state machine. So let's just make sure I'm not out of my mind here. State machine programming. So a state machine is a programming architecture that allows dynamic flow to states depending on values from previous states or user inputs. This architecture is suitable for applications that can be described as a combination of states, decision-making logic that determines when to move to a particular state. So, that's just a fancy term for... Let me just go back up here and I'm going to close all but this. And I'm actually going to start this... I'm going to start this in a script. Because why not? Actually, you know what? No, I'm going to just start with... test enemy here, and then we're probably going to migrate that code to a script later. So first things first, let's give this guy like let's see, he's going to be a big ship. So let's copy all of this stuff here, and I'm going to bring this over to the ship. So I'm going to just copy it here for now, and then what we're going to do is they only have 10 hit points. Holy cow. Gotcha. So now we've got all this stuff, and then we're also going to be defining like what ship they are. So I think these guys are, let's see, did I finish this? SCR init ship. Did I do... Yes, I did ship 2, which is the sprite that they're using. So I already plotted all that stuff out, so we can just do ship 2. Bam. So now if we save this, you can see the enemy ships. Well, they have weapons. It's just I don't have anything in the draw event to draw those. But you can see they're taking lots of damage now, though. So they're definitely taking some of that sweet hits. That might be too much. There we go. Yeah, now we're hitting them. Come back here. No, get back over there. Finish the job. Yeah, come on. Got him. So, we'll get to that in a sec. But now we at least have... some stuff defined here. So I think also what we need to define is we're going to need to define some AI variables. So one thing we're going to be doing is we are going to be defining first of all, we're going to have a state variable, and I'm just going to make this idle. So while we're actually at it, let's go to our types. SCR types. We've got so many scripts now. This is great. So what we're going to do here is we're going to add AI state types. Weapon types. There we go. So what we're going to do, macro state idle, and this is just going to be idle. So let's define some of the states that we want. So idle basically means like they're not doing anything. So idle state, I typically use it to determine like if there's no target nearby. So if the NPC that I'm programming is going to be idle, it's typically searching for a target. If it doesn't find a target that's like within its range or sight range or whatever, I might have it play different animations if it's like a character, or if it is in the case of this ship, maybe I might have it fly to like different points in the system and just wait. So we have idle state. We're also going to have a state for movement. So they're going to have to travel places. So we're going to have state move. So that's typically, I use that for if, hey, we have a target, but they're not within attack range yet, move closer to it. And then we're going to do macro state attack. And this is going to be when they are in range, we can attack. So that's basic stuff there, and then we can also add in other states as well. So I think I'm going to differentiate move and attack. So I might change macro state intercept, and this will be where you're moving to engage with an enemy. Whereas move might be like, during my idle, I might just set them to go to a different point and just have them move in that point. But intercept, they're chasing a target, so that's going to be the differentiating factor there. Let's see. I'm also going to want to have the possibility of a ship being disabled. So state disabled. And say, for example, like if I shoot a ship with like a EMP, it just knocks out all the power or something like that, and they're just drifting for a set amount of time. They shouldn't really take any actions while they're disabled. So that will handle all that there. And then I also want there to be a state where they are running away. So we can say state flee, or maybe I'll just state retreat. I'll just say retreat. There we go. So we have some predefined states, state types that we can work with. So now we can save this. We can go back up to our ship here, and we can change this to state idle. Okay, cool. So yeah, now that we have an idle state, we also probably want to work on... So we're going to start with idle state, then we're probably going to do intercept next, and then they're going to move at us. So let's try this out. So all this stuff here, AI stuff should go up top. So we're going to do AI state stuff. I'm going to put it to do here. Move this stuff to a script once it is better defined. So what we're going to do is we're going to determine state. Now I typically use idle as like the determining state. So, you know, if we're idle, we're searching for a target. Does a target exist? If it does, okay. Is it within our attack range? No. Okay, then go to intercept. Otherwise, just start attacking it, you know, that sort of stuff. So that's what we want to do there. So determine state. So what we're going to do is, I might, you know, I could use a switch for this, but I don't necessarily like the syntax where everything gets like indented another time, especially when you're doing AI, because then that kind of gets complicated. So what I might do is I might just use if statements, because I'm going to start with idle, and then if I assign another state, it just immediately starts executing that state later on. Whereas with a switch, it wouldn't start being executed until the very next step, which might not even be noticeable to a player, but you know, whatever. So we're going to do state equals state idle. So we're idle. Do we have a target? So we're going to need to have a target variable. I'm going to set this to no one, which is a special built-in constant that GameMaker has. I think it equals -4, but it's used for so that you can use like instance exists. So it works really well with that. So do we have a target? So what I can do here is I can say if instance exists target. We can say we do have a target. Otherwise, I can go else. We do not have a target. Does one exist? So we do have a target, and so we can say, are they in range to engage, I guess. So if instance exists, target. We do have a target. Are they in range to engage? So we're also going to need to have something to determine the range. So I think maybe I might expand upon this init ship, and I might make like a init NPC ship or something. Because a lot of this stuff, I'm determining, not that one, init ship. Here we go. Like a lot of this stuff here, I'm determining based on the ship. So they might have different ranges and stuff that they can have. And so that's really fun. That's fine. So let's go back up here. For now, I'm just going to get something working. So I'm going to say, let's do sight range. And I'm going to set this to be something like, I don't know, 1024. Actually, it will probably be a lot longer than that, because what's the max range on our weapons? So let's say SPR weapon here. So it expires. So it travels 15 pixels per step, and it lasts roughly 60 or 61 steps. So what's 15 times 60? 900. So they'll pretty much be able to attack. So I don't think we're going to have to worry about sight range, because pretty much like if you're in the system, you're probably going to be in range. So I'm just going to say attack range, and we'll just set this to 1024 for now. So now we've got that set. Let's go back to our step, and what we can do is we can say if, and we can calculate the distance of how far they are away. So distance to object, we can just specify target, is less than our attack range. I'll say less than or equal to. Then what we can do here is they are in range. Attack. So then I can say state equal state attack, right? So this is just basic decision making algorithm here. It's just, again, computers, everyone thinks they're really smart, but they're really dumb. They only do exactly what you tell them to do. And programming languages, which is how we tell them to do stuff, is basically just them playing the what if game, you know, several times a second. So yeah, fun stuff. So if the target, we're going to do an else here as well. They are not in range. Let's intercept them. So we can do state equals state intercept. I did a thing that was weird. There we go. State equals state intercept. Cool. So we've done that there. So that's the decision making. If we have a target, are they in range or not? If they are, attack. If not, intercept to attack them. So if we don't have a target, what do? We want to find if one exists. So because I did parent objects earlier, so if you look at my player ship and you see the parent object here, it's obj good guys. So what we can do is we can say, we don't have a target, does one exist? If instance exists, obj good guys. Let's see. A possible target does exist. I'm going to say at least one target exists. Get the closest target. And what we can do here is, I might do the target acquisition code first. That way it can run through here and hit this code block after. So let's just get this fleshed out, and then we might rearrange it to make sense. At least one target exists. Get the closest target. So target equals instance nearest my x, my y, and obj good guys. There we go. So what we can do is I might say if target equals no one, then I can move this here. And I can get rid of this else. Okay, so we already fired our code to find a target. We're going to be responsible for clearing out our target after we're done. So I also want to catch the case where maybe my target gets destroyed and it doesn't exist anymore, but I haven't set it to no one. So I'm going to do an OR statement here. So target equals no one, or instance exists target. So I put the exclamation point in front of that, which means it does not exist. So if target equals no one or instance just doesn't exist, either of those two cases, it's going to fire this code block here to get a new target. So cool. And then once it does that, it'll run to this code here. We've tried to update our target. Did we actually get one? So if instance exists target, then at this point, nothing can be done. So at this point, no target exists. Handle idle behavior. So I'm going to put to do on this because obviously I exist, so there's always going to be a target, but I might tweak that later to where, because it's not always going to be you versus everybody. There's going to be a lot of neutral ships that just don't really give a damn what you're doing unless you attack them. So I think in that case, we'll probably be seeing this idle stuff happen a lot. So we'll get to that soon, but let's see. So we have our idle state worked out. Now we're going to do if our state is to move. So movement intercept. So movement intercept, let's just change this to move state. And I'll put a to do on here because we're not going to be really moving yet. So we're going to do intercept state. Determine state, idle state. So just, there we go. So if state equals state intercept, Now we get into some fun stuff, because normally I would just make like my my enemy guy just walk towards my player character, or whichever the target is, and you could just set like their sprite to like do a walk animation or whatever, and then you're good to go. But for this, because the movement is not just, you can't just go point A to point B, you have to like rotate your ship and then accelerate in that direction, and then if you get slower, you probably gotta slow it down, or if you get closer, you probably have to slow it down. So that's going to be a bit more involved. So what we're going to do is we're going to say we need to intercept our target. Are we facing the target? So what we can do is, if I'm going to say image angle equals, I'm going to say point direction. Yeah, point direction. So my X, my Y, target X, target Y. Now we're referencing target here, and we want to make sure that that exists before we start doing stuff. So what we need to do is, does our target still exist? If instance exists, and we're going to say target, and I did a exclamation point, which means not. So if our instance does not exist, then what we're going to do is target no longer exists, just go back to idle state. And we're going to say state equals state idle. So what this will do is this will catch that edge case to where, like, you know, we've already calculated that we have our target, we've already calculated that we want to intercept them, but when we get to the intercept code, for some reason, maybe they just don't exist anymore. Now, I don't think that's ever going to happen, but just in case it does, we have this covered. Because if we didn't have this, this would be like some weird obscure bug that would just haunt my dreams forever, that may or may not ever happen, but if it does, it's going to suck. So anytime you're working with instances, you always want to check that they exist before you start doing stuff with them. So that's why I'm throwing that there. So if image angle equals point direction, I'm going to say does not equal point direction. Let's see. We are not facing our target. Rotate and face the target. So what we're going to do here is that our ship is not going to instantly go from here to here and start chasing me. It's going to start rotating. So we already have the variables for that. We already have turn speed. So we'll go off of whatever that is. But first we need to determine which is the quickest direction to turn. Because if we're here, like shooting this guy, and he's facing this way, we don't want him to start turning this way to try to eventually get around to come face me and come at me again. So we want to be able to detect, like, hey, turn here and then go at him. So we want to make sure that we're handling that. Let's see. I'm going to save this as TD for target direction. And I'm going to cut this and I'm going to say TD. That way I'm not doing this calculation a bunch. So how are we going to determine this? So let's think about it. So we have a spaceship, you know, here. You know, say this is me, and then like this is like the enemy ship here, right? So looking at this, we know that it should turn to the left. or counterclockwise. But the computer doesn't know that because it's dumb. So what we need to do is, so say for example I am facing 0. That's the direction I'm facing. And then this ship is facing, I think this is actually 90. It's facing up. So we're going to need to face, I guess it doesn't matter where my ship is facing. The only thing that matters is that to face my ship, it's going to be 180. So again, direction 0 is over here. 270 is down here. You know what? I'm thinking about this too hard. GMS2, determine which direction to rotate. Turn character to a target direction, taking the closest side. Ooh, angle difference function. Look at that. GameMaker has a built-in difference. So this function will return the smallest difference between the two specified angles, where the difference is calculated from the source angle towards the direction angle. The returned value will be between -180 or 180, where positive angle is anti-clockwise and negative angle is clockwise. Okay, cool. Sweet, so we've got that. So we're going to say var, I'm going to say AD for angle difference equals, we're going to angle difference. The destination that we need is going to be TD, and our source angle is going to be our image angle. So then what we can do is that we can say if AD is greater than 0, that means it's positive. That means we're going to turn left. That means we need to basically add our turn speed. We're going to say rotate left or counterclockwise to face our target. And we're going to say image angle plus equals turn speed. Else rotate right or clockwise to face our target. And we're going to say image angle minus equal turn speed. Okay, so this should work in theory, but there's one problem. The problem is like, what happens if we're off by like 1 degree or something small? And you know, we handle it, we turn our turn speed, and now we're off still, but the other direction. We're going to keep going back and forth. We need to handle that. So what we can do is maybe we can say if AD is greater than our negative turn speed. Actually, no, we'll do AD greater than 0. Let's see, rotate left. Do we need to only rotate slightly? Not slightly, slightly. So what we're going to do is say if AD is less than turn speed, then we're gonna do image angle just equals TD, I would say, because we're just gonna face where they are. So yeah. Yes, just face the target direction. Now we're going to add an else here to cover this case. We're going to say no. We need to turn the full amount. We need to turn as much as we possibly can. Okay, and all we're doing is just boom, putting that there. Now we need to do something similar here. So what I'm going to do is I'm going to copy and paste this down here. And I'm going to say AD is greater than, since this is supposed to be a negative, I'm going to say turn speed times -1. So a negative times a negative turns it into a positive. So we're still going to be doing the same calculation here. If AD is less than, you know, the difference in our turn speed, and I think we're going to make AD a positive as well, times -1. Wait, our turn speed, never mind, I'm dumb. Our turn speed doesn't go negative. It's only the angle direction, the angle difference that goes negative. So we can do turn speed. There we go. Yes, just face the target. No. There we go. And we'll do minus equals turn speed here. Cool. So I think if we run this code, it should try to face us. But it's not. It's a bit of a bummer. Why is it not working? Oh, because we're in range to attack still. That's why. So if we go here and we change this to something stupid like 0, like 1. There we go. Now they're all rotating towards us, see? Look at that. Anyway, cool. So that's fun. Now we know that state's working. That's fantastic. So intercept, they're facing us. So now what we can do, if image angle doesn't equal TD, cool. So we're doing that now. So we've updated that. We've updated our direction. Are we able to move towards the target? So what we can do now is we can say, we can check if, and we can say image angle, not alpha angle, equals TD target direction. So we should have already updated that. So it should equal target direction, or if not, they're still turning and trying to get towards us. So then we can say, we're facing our target. Let's get some thrust action going. Woo! So what we're going to do is we're just going to take the same code that I have up here for like keyboard check. And we're just going to do motion add. And we're just going to, I'm probably going to copy all this stuff here. So yeah. So what we're going to do here is we're going to say, boom. Let me indent this stuff here. Motion add. And I'm not going to play the sound. Actually, my play loop sound, that's already checking if I'm playing the sound, right? Yeah. So if the sound is already playing, it's not going to do anything. So that's fine there. And it's going to emit its thruster particles. Cool. Yeah, accelerate in the direction I'm facing. Cool. So there we go. So if I save this, these ships should start, like, accelerating towards me. Oh no, they are! Oh no! Yeah, come get it, noobs! So the shields look really bad, especially when they're moving. So that's fun. So now they're just gonna keep trying to come at me, which is hilarious. And I'm sure we'll probably pass them. Let's see, where are they at? Oh, there they go. There they go. So they're not smart enough to stop yet. So it's pretty nuts. They just keep coming after me, and they won't stop until they get me, and even then they're not gonna stop. So let me just stop and then see if they can figure it out. I don't think that they can. Yeah, they're just flying by. Holy cow. This guy's figuring it out. This guy almost figured it out. Nice. So, good stuff. So what we need to do is that we need to say, right, so that'll only, so I'm going to leave this alone for right now. I mean, we've got this working. How long have I been recording? So we've been recording for 41 minutes so far. Let's change this back. I'm going to save to 512 for the attack range. And then what we're going to do is in my room, I want to move my player ship out of the way to give a little bit of a head start before they start just coming after me. Maybe I might move these like all around the map. I might just put me like right in the middle. Yeah, this is fine. Okay, cool. So now we've got that. Let me save that. Close the room. Now we need to work on our attack state. So what we're going to do here is if state equals state attack, we're going to do this stuff here. So first thing that we need to do is our target still exists. We're verifying that. Are we in range to engage our target now? We're going to say if distance to object, we can say target. Again, we already verified that they exist here, so we're clear there. We can say distance to target is less than or equal to attack range. They're in range. Attack. And we can just say state equals state attack. There we go. So now we've got it transitioning to attack state, and now we need to figure out what attack state is going to do. So I would say what is our ship doing? So update weapon slot position and fire weapons. So first things first, let's copy this code here and move this into this own ship's draw event. There we go. So now we should see weapons on the ships, on the enemies, and that will be fun. And you know what? I'm gonna make these guys. I'm gonna make these guys the little small shuttles. I think that'll be more fun. So let's see. State equals attack. first things first, we always need to verify if our target still exists. So I'm going to put that here. Target still exists. Fire! So if I take a look at this, update weapons slot and fire weapons, I might have to modify this so that it will work for AI as well, because yeah. Because I still need to also update the weapon ships. So how am I going to handle primary, secondary, independent weapons for AI? What I might do is I might just make these arguments. So I can say primary, secondary, and I can just I'm going to control F. I'm going to say primary input and secondary input. And these are just things that are going to evaluate to true, basically. I'm going to say, I'm going to change these to fire primary and fire secondary. So I am going to control F and search for this. And I'm going to change this to fire primary. And I'm going to change all that. And then we're going to do right click. And I'm going to fire secondary. Replace. There we go. So now we can get these out of here. So this is a breaking change. So let's save this. And then what we're going to do is in our ship, our step event here, we are going to pass in. Oh, whoops, it changed it here too. I'm going to say left click. I'm going to change this back. Right click. So we'll do left click here. Right click here. So this is just returning if we should be firing or not. So let me just save this change and run it just to make sure that it doesn't crash on me. Okay, good. So we're still able to fire. Oh my god, little ships are coming after me. There we go. Cool. This is fun. Little stupid ships. I love it. Cool. So that works. So now what we need to do over here is I'm just going to say primary. Yeah, we'll just do fire primary and equals false. Fire secondary equals false. And what we're going to do is we're just going to update these. So state attack fire to do determine better behavior for primary secondary attacks. Okay, so what we're going to do is we're just going to set these to true. Okay, and then what we're also going to do is back up here in our idle event, ensure AI variables are reset. So I'm going to set these to false. That way they don't keep firing, which would be bad. So yes. So what we want to do is while we're attacking, we want the fire to basically be true. I think there might be some more steps ahead of this, because right now, when they're trying to intercept, they're doing this, you know, facing target thing. But and this is why I was thinking about doing code earlier, like scripts, I mean. So I'm going to just copy this whole thing here, and I'm going to move this into my state here. So we need to attack our target. Are we facing the target? Rotate and face the target. Determine which is the quickest way to turn. Cool. So now we should be facing the target, right? So what we're going to do, yeah, target still exists, fire. I also want to add, we should try to slow down so that we can better engage our target. So what I'm going to do here is, what am I doing to decelerate here? I'm just saying speed minus equals dex speed. Okay. So we're going to do this here. And in our step event, we also want to add in these safeguards for our speeds. Okay, we did that. Cool. So now we don't have to worry about the speed going negative. And it should be facing us. And this should all be set to true. Now, add event. I did the end step event for that. So if we go here to end step, you can see that we've got this. This is all camera position stuff. We don't need that. We don't want the camera following the bad guy. I want the camera following us. So what we're going to do is get rid of this, because this is actual input, and we can just say fire primary and fire secondary. Save. So now there's another problem with our code, but let's run it and see if it works. Okay. That's the problem. Very nice. So, these guys are killing themselves because in my code... Oh, where is it? In my code, when I'm firing, and I'm creating the projectile, I don't have anything in place to determine to collide with good guys. All we're doing is if we're colliding with enemies. So I'm going to copy this. I'm going to add event, and I'm going to do collision with obj good guys. If not enemy, are we intended to hit a good guy? Okay, cool. So now we've got that. So in our projectile state here, I don't think I'm even updating this stuff. I think it's just the projectile is just defaulting to true. Yeah, defaults to targeting enemies. So I'm not setting that. So what I need to do is I need to determine if this should hit an enemy or not. Now, how can I determine? Let's see. GMS2 determine parent. object get parent. Parent equal object get parent object index. So I think I can probably do self, maybe? Yeah, we'll do this. Proj for projectile dot enemy equals, I'm going to say, so let me do something like this where I can say object get parent self equals obj good guys. We're wanting to do bad guys, so obj bad guys. If object parent equals bad guys, no, we had it right. If object parent self equals object good guys, then this whole thing here should evaluate to true, and it should set this to true. Otherwise, it should set it to false. And we'll see what happens now. This is probably gonna crash my game because I don't think I have life variables. Oh, I do! Oh, I do! I'm getting my ass kicked! Bring it, fools! Oh no, I'm shooting myself. That's a problem. That is a problem. So that's fun. That's awesome. GMS2 determine object. You know what? I'm just gonna make that a argument. So I'm just gonna say equals enemy, and for this here, I'm going to accept enemy, another true or false, and what we are going to do is for fire weapon, we're also going to accept enemy. Okay, save. So now what we have to do is we have to update our test enemy event here. We're going to say false, and we're going to say true. Okay, so okay, I'm able to shoot, they're able to shoot me. Now we got a war going on. Oh no, this is bad. Okay. So our ships are just endlessly firing because we don't have anything to check for if they are outside of our attack range yet. So let's go back to our test enemy ship here. And in this step event, what we want to do is, does our target still exist? And we also want, are we even still in range? So what we can do up here is we can just do the same calculation we did here. If distance to target, I'm going to copy this and paste it down here. I'm going to de-indent it. So I'm going to modify this. If distance to target is, I'm going to say greater than attack range. We're going to say they are not in range, but they still exist. Intercept them. Okay? So now we're going to do state intercept. Cool. Fun stuff. So they're trying to intercept me, but they're also still firing. Oh no, my shields are down. You'll never get me, scumbags. Oh no, this is great. Fun stuff. Okay. So what I think we might do instead is, instead of going back to state intercept, I kind of want to keep going back to state idle, because idle will go through and acquire the target, Go back to idle state to reassess next move. So I'm going to change this to idle, because what's happening is once they get out of range, they're... let me move this here so we can see. And these are never getting reset, so those are still true. And they're just non-stop firing. So, yeah. I think this should work now. So hit save and run it. Okay, they're coming to get me. They're coming to get me. They're shooting. Okay, they're out of range. They're no longer shooting. There we go. Now they're coming to get me. Look at that. I did not expect to get this far in just one episode. You never get me, suckers. What are they doing? Where are they? I know I didn't kill them. Where are they at? Oh, there they are. Oh, God! Oh, that's fun. That's funny. I like that. Whee! Oh, they're over here now. I'm gonna get you. I gotta lead them. Oh! I crashed my game because I died. So I haven't added any death code. Actually, yes, I have. To determine how best to handle player death. Because we don't want to instance destroy. But yeah, anyway, there you go. We have working AI. That's fantastic. Look at that. Come at me, boys. All right, I'm gonna try it again with a different ship. So where is my create event? I'm gonna do ship 1 because that way I have a rocket launcher. We'll see if I can get that to work. Yeah, come at me, losers. Oh, I missed them. They're hard to hit. Oh no. I can't hit rockets to save my life. I'm dying. Oh no. Oh yeah, I got one. Get it. Yeah. Stupid little ships, you can't take me. I'm a beast. I'm unkillable. Yeah, this is great. Okay, seriously though, rockets need to do way more damage. Boom. Yeah, get it. That's fun. Cool. Alright, just for one last test, just for one last proof of concept, if you will, I'm gonna say, to do, remove this testing randomization. And I'm gonna say, I'm gonna put choose. Choose is like a randomized thing that lets you choose like a different thing. So SPR gen ship. I'm gonna say ship 1 all the way up to ship 4 because all of these are currently working. Boom. Okay, cool. So that's test enemy. Now let's run it. We should get a bunch of different ships that are attacking us. Oh god. So we got our little ship over here. We'll take him out. Oh god, we got the big guy. He's shooting rockets at me. Oh god, I need to get out of here. Oh no, they're all after me, baby. Oh god, this is so bad. Just keep going. You little crappy ships, get out of here. Woo! Yeah! Come get it! You won't do it? You won't do it? Stupid little ships, I'll take you down, eventually. There we go. This is what I'm talking about. This is worth it. Flying through endless space, fighting ships. Oh my god, the shields look like crap, but I'll get to those later. Yeah, suck on that rocket, pigs. Oh no, you keep moving. Oh man. Nice. Oh, you know what's funny? Their turrets are still going off of my mouse XY. That's hilarious. This is great. I mean, so far, like, the sound effects aren't bad either. Come on, I'm gonna get one of these ships eventually here. I can't just let them just do me like this the entire time. Come on. Oh man, they're launching rockets and stuff at me and everything, man. I still got those little ships orbiting around me. That's great. Okay. You get the idea. We've got AI working. Holy cow, that was fun. So obviously there's a few tweaks we need to make to that. First of all, not every ship is going to be an enemy, so that's going to be fun. But yeah, that's a good start. Thank you all so much for watching, and I'll see you in the next video.